Hi and welcome to the KSEdTech YouTube channel. In this tutorial, we'll be learning how to download point cloud data for relatively high accuracy 3D data, which you can use to measure, model and visualize an area of interest. To start, we'll need to open up Digimap and click on the LiDAR tab. Then LiDAR data download. From here, you'll have to log in with your university account. You can do this by typing in the name of the university or searching from a list. Once you've found the university, you'll be shown a map of the UK. From here we'll find our site. To use a familiar site, we'll use the university campus, since it has a nice mix of large buildings and green space. It's an excellent example of the data we get from Digimap. For this video, I'll be grabbing an entire tile, as this is best practice when downloading data, particularly multiple types of data, in case you wanted to overlay them using the embedded GIS data later on. To see the available tiles, we'll expand the point cloud section. The location you need will require you to search through different years of available data, as there isn't a composite record of point cloud data. I happen to know that the tile I need is located in the 2014 section of point cloud data, which I can verify by clicking on the grid icon here. Once I've entered the tile name and selected our data, we can now add this to our order and submit it after giving it a name. Once submitted, we'll receive two emails. One to confirm our order, and the second will allow us to download our order. Once we've downloaded our order, we can extract it by right-clicking on the file and selecting Extract All. Now the data is extracted, we can open and use it in Recap. Once Recap is open, we can select Scan Project to get started. Now find the files you downloaded from Digimap. At this point, Recap will start indexing and registering the data, and this may take some time. Once it's complete, click Launch Project. Once loaded, change the colour mode to elevation to see the data more clearly. We can then use the selection tools to select and delete the areas we don't want, which once saved and unused points discarded, will improve the performance of the machine, as point cloud data is very heavy. Now we'll move on to working with point cloud data for measuring or modelling. In this part of the video, we'll cover basic modelling using point cloud data. First of all, we can measure and recap using the measure tool. This will be relatively accurate, but does have a certain tolerance for error, which may be plus or minus 10mm or more. This is due to a more coarse point density, since the scanning is done from a satellite. This will be more than sufficient for the scale of data you need, as an inaccuracy of a few millimeters will not be significant when used in a scale drawing or model. You can also use the point cloud data in Autocad to create a 2D plan. To do this, open Autocad and start a new drawing. Make absolutely sure that your drawing units for this drawing are set to meters, as the point cloud data we insert will be in meters. On the Insert tab, navigate to the Point Cloud section and select Attach. Make sure the file type is set to RCP and find the file you saved from Recap. Now just click to place. Once the file is inserted, we'll need to change the colours of the scan just like we did in Recap. To do this in Autocad, we'll need to select the point cloud and click the arrow just below the Scan Colours button. I'd recommend selecting Elevation. By default, Autocad chooses the Earth colour range, but if this isn't very clear, you can change it to a few different presets. To change this, click the Colour Mapping button. In the Colour Scheme drop-down menu, you have several presets to choose from. Choose the one that stands out most to you. For the purposes of this video, I'm going to use Spectrum. Now we need to create a layer to draw onto. Click the Home tab and select Layer Properties. Click to create a new layer. Give it a name, change the colour, and make it the active layer. We can now begin the process of drawing over the point cloud data. You can of course do this freehand, but this may be difficult, and we can use snap settings to snap to the point cloud nodes we see. To do this, first turn off the grid and right click on the snapping button and select Snap Settings. Navigate to the 3D object snap settings and make sure that vertex, center of face and node are ticked, then turn on 3D object snap by using the checkbox up here. Once this is done, you can use the Polyline tool or P-line command to trace the extent of the building. I'm going to fast forward through this process. You should note that you need to draw one continuous polyline starting and ending on the same point. This is because when we snap onto these nodes, it snaps onto the elevation of that point, and using the line tool or interrupting our polyline will cause our lines to be at different heights, or even worse, be connecting 2 points not on a 2D plane, but travelling through the z-axis, potentially making the line an incorrect length. Starting and finishing with one line on the same snap node will make sure that the line is a 2D surface. Once we've traced the extent of our building, we can now hide our point cloud data by using a layer manager. Now we can get a clear look at our building, but as I mentioned earlier, our line is at the elevation of the first point that we snapped onto. In order to solve this, we'll need to select our polyline, right click and select Properties. Under the Elevation or Position Z section, change whatever value is in this box to 0. Moving to a 3D angle and activating the point cloud data, we can see that we have a 2D outline of a building that we can measure or draw from. So, thanks for watching this tutorial. Please feel free to check out our other videos, and don't forget to subscribe to our channel so you can keep up to date with videos as they're released. We hope to see you soon, but until then, have a good day.